If a book was completely written by an AI bot, would you read it? If your answer is yes, just think about the Batman script Keaton Patty made an AI to write, which contained dialogue such as, "This is now a safe city. I have punched a penguin into a prison." So, what can we understand from this? Even though AI, due to its vast vocabulary, can produce grammatically accurate sentences, there is a very high chance of these sentences sounding completely absurd to human readers. I mean, what's with a penguin being punched into a prison? Similarly, even with powerful automated testing tools like Selenium, Appium, Catalan, Test Complete, etc., human testers are still required to test the software from a user's perspective. However, since manual testing is solely dependent on human labor, it is prone to cause major delays in production. But the reason why it still persists is that certain tests, such as exploratory testing, ad-hoc testing, and usability testing, which we'll discuss in the upcoming slides, can only be performed by humans. So, in a nutshell, manual testing is not going anywhere. And no, it is not a dying career. Now, if you're convinced enough, let's start with this video. Today, we'll be covering the top 30 most asked manual testing interview questions and answers, which have been divided into 3 groups: beginner, intermediate, and advanced, with 10 questions each. But before we get started, if you haven't already, then hit the like button and subscribe to our YouTube channel to never miss out on any updates from us. Now, without any further ado, let's get started. So now let's start with the basic model with our very first question. What is manual testing and why is it important? Now, say you are about to launch an e-commerce application, you're about to launch it, like it's production ready, you're just about to launch it. So now the manual testers have to go through a couple of things. Like they have to manually add products into the cart, they have to apply coupons to check if the discounts are applying correctly, then they have to complete the whole procedure of the checkout. Let's look at the technical definition so that you can get a clearer understanding of this. Manual testing is a software testing process in which test cases are executed manually by a tester without using automation tools. Now, the interesting part is that all of these processes, such as adding products or applying coupons or completing checkout, can be automated as well. But why do still manual prefers do it? That is to check how good the user interface of the website is, like adding the products to the carts. Is the customer easily able to add products into the cart? Is the customer able to apply the coupons? Is the customer able to complete the checkout easily? Is all of this process very seamless and easy for the customer, or are they getting confused in the user interface? Now, a machine would not know that if a real user is getting confused or not. Only a real human can know if such a confusion or a blunder is happening in the user interface. That's exactly why manual testing is important. Now, manual testing involves validating the functionality, usability, and performance of an application to ensure it meets the specified requirements. Moving on to our next question. Can you explain the software testing lifecycle? What is the software testing lifecycle? Say you're trying to bake a cake. Now, unless you're an expert cook who already knows everything, you would try to follow say a recipe book, or you try to watch a YouTube tutorial, or you might actually go around and read a blog as to how to bake the cake. Now, what your idea behind this is, you're trying to understand, you're trying to figure out the process of building the cake from the start to the end stage. STLC is similar to this. It is also a process consisting of multiple phases that define how the software is tested, from the planning to its execution and its closure. Now, there are different steps in a software testing lifecycle. Let's look at them one by one with the help of an example. Say you have a mobile banking application. Let's look at the software testing lifecycle for this particular mobile banking application. So the first one is your requirement analysis. So this mobile banking application is already built. You're checking, you're testing it. Now you're testing to see its features and everything. So the first step is requirement analysis. The testers analyze what features needs to be tested. The next one is test planning, where a strategy is created, deciding what needs to be tested and by whom. Now, obviously, testing each and every component, they all have different priorities. We'll explore more about priorities in the upcoming modules, but keep in mind that different testing functionality has different priority levels. Like you being able to change the application's theme to light or dark is not as important as your banking application being able to scan another person's QR code correctly. What if its QR code scanning part is wrong? What if there's some error in that QR code scanning? Then you will be sending the money and it will be going somewhere else. So obviously that part has a higher priority as compared to setting the theme of the application. So hence creating a strategy which assigns the priority of the test and analyzing it to the person who will test it is equally important. Next step is test case development, where you write down the test case, where you cover all the edge cases and what kind of values you're going to test or how you're going to test. Next, you have test environment setup, in which setting up the test environment, like simulating the real world conditions, or maybe say if your banking application, you have an e-commerce application. Repeat, say you have in the same banking application, if it's like the day your salary is getting credited at the end of the month. So a lot of users will be opening the phone and checking salary aa gaya. So at that time, the load balancer plays a very important role, because if the servers are not able to handle that load in that kind of pressurizing situation, then obviously the entire app crashes. Next one is test execution, where you run the test cases, report bugs, and verify fixes as well. And lastly, you have test closure, where you document everything for the future, because there is a very high chance that obviously you're going to keep on if this app runs well in the market, then you're going to keep on adding new features into this application. Hence, whenever you add a new feature, a new bug will pop up. And at that point, if you document everything right now itself, in the future when a new bug pops in, these documented features will actually help you resolve the bug, which we will see how in the upcoming modules. Moving on to our next question. What's the difference between verification and validation? Now, verification, just bear with me, the technical definition, I know it will go over your head, but just please bear with me, because before understanding the technical definition, you cannot understand the example. So, verification is a process of evaluating work products such as requirements, design, and code. It ensures that it meets all the specification before execution. I know, but fine, just understand that. You'll understand this better when you have the example. Next is validation, the process of executing the software to ensure it meets the intended user requirements and functions correctly. And it is a dynamic process that includes functional and system testing. Moving on to the example. Say you're building a bridge, not you, a bunch of people are building a bridge. Now the initial construction workers, when they're building the bridge, they already have the blueprint and all ready. So what the kind of questions that they have in their mind is, are the pillars placed correctly at the correct distance as per the design, as per the blueprint? Is the concrete mix correct? Is it the right amount? Will it be solid enough? Do the cables follow the engineering plan? The blueprint is already designed. So are we following the blueprint correctly? Or in other terms, are we building the bridge correctly? You already have a blueprint, you're building the bridge. Are you copying the same thing, or are you following the same thing the blueprint requires you to do? That is called as verification, when you're building the software based on the plan that you have already developed. Now, after the bridge is built, the engineers come to check it, who have initially made the blueprint, they come to check it. Now, the questions that they would ask is, can the bridge hold, if there are heavy trucks going on the bridge, can this bridge hold their weight? Is the bridge stable during really strong winds? Does it connect two cities properly without any issues? Is the road correct? Is it smooth enough? Now, these kind of questions are, did we build the right bridge? What if the bridge is not built for stronger winds? What if there are strong winds and the bridge starts swinging? So, when we made the initial blueprint, was that right? Did we build the bridge right? That is called as validation. Or if you summarize the differences between the two of them, now let's look at the technical definition again. Verification, the process of evaluating work products to ensure they meet the specifications before executions. And validation is the process of executing a software. Validation is actually executing after you've done everything. Verification is just building it right. Like if you have a code, so you're typing, like your manager asked you to build a code for a banking application. So you write down the code for the banking application. That's verification. Validation is once you launch the product into the market and the customers try out that product, and what if they don't find it easy enough? What if they think, oh, this app is very complicated, I can't use this. I don't even know where the UPI option for scanning is. I don't know how the transactions are happening. I can't see my payment history. It's very complicated, I'm not going to use it. That's validation. Did we build right? And verification is, are we building it right? Now, if we summarize the differences between the two of them, verification, checking specs, documentation, and the code structure. Code structure, like I said, it's like your manager asked you, build a banking application. In your mind, it will be, okay, I have to write the correct code for banking application. I have to add the method for transactions, for payments, everything. Validation is checking the real world functionality and usability. Are the users able to use it? Is it actually beneficial for them? So verification is usually done before testing, and validation is done after testing. Next, we have the example of verification. Is the login feature coded according to the initial plan? We planned that the login should be like this. Did we write the correct code for the login feature, or did we just write something else which doesn't even match the blueprint? And the validation is, can users actually log in without confusion and errors? Are they able to find their usernames? Are they able to find the sign-in button? Are they able to reset their passwords if they forget their passwords? Moving on to the next question. What are test cases and how do you write a good one? Now, test case is a documented set of conditions, inputs, actions, and expected results used to verify that a specific functionality of a software application works as intended. Test case, if you remember, we have just discussed in the software testing lifecycle, there was test case, writing a test case. Now, test case is obviously a document which contains certain conditions. These are the values, these should be inputted into the particular, say, if you're testing out the transaction, the QR code scanner of a banking application. Now you have to make sure that the camera is opening up at the right time. The correct QR code which is linked to the other person's bank account is getting scanned, and the payment pipeline is activating, is working seamlessly. There is no other third party getting involved and attacking your bank account or something. That is writing a test case. Now, how to write a good test case? Keep it simple and clear. Write test steps in a way that anyone can follow. Don't add like too much complicated stuff that people are not, like half the people are not even able to understand what you have written. That should not happen. Next, make it repeatable. That the test should be executed multiple times. Okay, what they're trying to say is, say there's a button for adding items to the cart. In Amazon, you must have seen add items to the cart. Now, it should not happen that one time you're clicking and an item is getting added to the cart, and the next time you're clicking, it's not like nothing's happening. Like it's not getting added or some other feature is happening. The result should be consistent every single time. That is, no matter how many times you click on add to cart, the item should be getting added to the cart. Next, include preconditions such as mention setup conditions that the user must be logged in or seats should be available so that any other confusions should not happen. Like if you're booking a movie ticket, then before you reach the payment module, a seat should be booked. Without that, the payment module, the gateway to the payment module should not be opened under any circumstances. Next, define expected results clearly. As in, don't just say it should work. Specify what success looks like. Like if you're saying that the user should be able to book a ticket, the ticket should be booked successfully. So instead of saying the ticket should be booked successfully, write in the test case that a confirmation email or a confirmation message should be sent to the user's email. That is how the successful test case should look like. And you need to write that down. Don't just write that the ticket should be booked. Don't do that. Next, we have cover edge cases. Now, edge cases are very, very crucial. Think about what could go wrong and write test case. Like the first case would be if your UPI app is able to scan the QR codes correctly. Next is like you're scanning it and suddenly the network the network stopped working. That is an edge case. So make sure to write that as well to prevent unexpected bugs or errors. And these are the 5 ways in which you can write a good test case. Moving on to our next question. Explain the concept of black box testing and white box testing. Now, this is an interesting concept, and if you must have learned about software development before, you must know about this black box and white box testing. Now, say you're going to buy a new car. Now, don't come here and attack me about, no, I checked this, I checked that as well. I'm just giving a generalized example. So, if you go around to buy a car, there are certain things you make sure of. Is your car able to start properly? Is it driving properly? Is the brakes applying properly? Is the other functions of the car, is it working? Does the car have a good mileage? These are the things that you check. Now, this is called as black box testing, in which you focus on testing the functionality of a system without looking at its internal structure or code. Not in case of the car. In case of other software systems, you don't really look at the code. You just look at how the app is functioning, like such as an e-commerce website. You don't really try to look at how the code is working for the e-commerce website. You just know that, okay, this is working for me. I can buy stuff from here. Now, similarly, if a car mechanic is looking at this car, other than checking if it's driving and everything, he would also check the hood of the car. He would inspect the engine. He would inspect the wiring. He would check the fuel system. He would check the internal structure of the car more carefully because he's a car mechanic. And now such a situation is called as white box testing, where it focuses on testing the internal logic and the structure of the code. Or in case of your software world, you have an ATM application. Now, what the tester is more concerned about is the ATM dispensing the correct amount of cash? Is the transaction receipt showing the updated balance correctly? Now, Is the ATM providing a clear success message? These are all the things that the tester is concerned about. And notice how any of these things, tester doesn't have to be concerned about the code. All the tester is concerned about is the usability of the ATM. Is it working as it was supposed to work? That is what the tester is concerned about. Now, in case of a developer, what they will be more concerned about is that every conditional branch is behaving as expected, as in a valid pin and an invalid pin is working correctly. A valid amount that you're entering into the ATM and an invalid amount is working correctly. All the logical paths, loops, and execution handling methods are covered. Or each line or branch of the withdrawal process has been executed during testing. Now, if you keep in mind, all of these things are concerned about the logic or the code's structure or the internal working. That is called as white box testing. Moving on to our next question. What are test scenarios and how do they differ from test cases? We already covered what test cases are and how to write a good test case. But what do you mean by a test scenario? Now, say you have a shopping website. Now, a test scenario is like verify that users can log in successfully. Instead, now a test case is that the user will be able to open the login page, enter valid username and password, click login, verify homepage loads. Now, if you look at the difference between both of them, you can see that in test case, the instructions, there are a bunch of instructions listed here. And test scenario is just providing an overview that verify that users can log in successfully. And test case is that how do you know that a user is able to log in successfully? They're able to open the login page, they're able to enter a valid username and password, they're able to click the login button, they're able to see the homepage loading in front of them. This is how you verify that a user is able to log into the website successfully. Test scenario is an overview. You remember how in the previous question I said ki don't provide that the ticket should be booked successfully. Instead, let the users have a message sent to their email so that they know they're able to actually book the ticket. Now, just saying that the ticket should be booked successfully is a test scenario where you're giving an overview. And the test case would involve you to telling the tester as to what to test. That you have to test if a message is being sent to the user's email. Or in technical terms, test scenario is a broad, high-level description of what needs to be tested. It defines what to test, but it doesn't really specify as how to test. It's just what to test, an overview. Ticket should be booked. Users should be able to log in, but not how. It's just a broad overview. In contrast, test cases is a detailed step-by-step guide on how to test a specific scenario. It includes inputs, expected outputs, and conditions, like we saw previously. Moving on to our next question. What's the difference between functional and non-functional testing? Let's understand this with the help of an example. Say you have a car. Now, the functional requirements of this car is, does the car actually work? That is, does it start? Can you start it? Do the brakes stop the car? Does the GPS, is the gears in the car working? Is the accelerator working? Is the brakes working? Is the GPS working? All of these are the core functionalities, or the basic functionalities which make the car. This is the functional components, the core components. Now, the non-functional components include how well does the car work? Is it fuel efficient? Does it handle well at high speeds? Is it comfortable on long drives? Or in technical terms, functional testing is a type of software testing that verifies whether the system behaves as expected according to the requirements. It tests specific actions and outputs to confirm that functionalities are working correctly. Non-functional testing is a type of software testing that evaluates the system's performance, usability, reliability, and security rather than its functional correctness. It focuses on how well the system operates under various conditions. Now, both functional and non-functional components are equally important. Why? Because functional testings make sure that your car's core components are working, like your car is able to start, your car is able to brake, your car is able to accelerate. All of these are core components. Functional testing makes sure that all of this is working. But now, say your car is able to follow the functional requirements correctly, but after 10 minutes of starting the car, it overheats. Now, that's a non-functional requirement, that the car does not overheat after 10 minutes. So if the car is failing to do so, then it's failing the non-functional testing aspect. Hence, both the functional and non-functional testing are equally important. So from a software's point of view, the functional requirements would be, can users add items to the cart? Does the checkout process complete successfully? Does clicking place order trigger an order confirmation? All of these are core components. Adding items to the cart, liking them or saving them for later. All of these are the core components of a shopping website. Non-functional requirements are more like, does the page load under 2 seconds? Do I have to wait forever for the website to load? Now that can frustrate users, and obviously the traffic to your website can reduce greatly. Is the website accessible for people with disabilities? Can the website handle 10,000 users at the same time without crashing? Is the server able to balance the load? Is the server able to take the load of 10,000 people at once? Moving on to our next question. Can you explain exploratory testing? When would you use it? Exploratory testing is one of the very, very important tests when it comes to manual testing. Exploratory testing is a dynamic and unscripted approach to software testing where testers actively explore the application to identify defects, usability issues, and edge cases without predefined test cases. Now, the interesting part about exploratory testing is that you don't know how to test the application. You're just given the application and now you have to design the test cases yourself. You don't know the test cases. You don't know anything about the software. You're just given the software and your manager tells you, test karo. You don't know anything. You have to do everything yourself. But the interesting thing about exploratory testing is that you keep on testing everything and then you document it. Then usually what happens is that you're given the document first and according to the document you test. But in exploratory testing, it's like reverse engineering. You have the website, then you write the document. Let's understand this better with the help of an example. Say you have a banking application. Now you randomly try to log in with a weak internet. You try to rapidly switch between pages. You try to input unexpected characters. You keep on tapping on random parts of the screen so that you can channel that user frustration. Is it working in such a frustrating situation? You try weird combinations of actions to see if the app is able to block weird combinations at the right time. Now, exploratory testing is essentially used when you don't really have a document and you have to prepare the document yourself and you have to find unexpected bugs. Now, you don't know where the bug will pop out from. So, you have to try everything. Now, when should you use it? You should use it when the requirements are unclear or incomplete. You should use it when you need a quick feedback for complex or new features to supplement automated test for usability. Again, for usability testing, manual testing is usually done for usability testing only, to see if the real world users are able to seamlessly use your application. Moving on to our next question, what's a test plan and what key elements does it contain? Now, a test plan is a formal document in software testing that outlines the scope, approach, resources, schedule, and objectives of the testing process. Now, the core of test plan is three things: what needs to be tested, how it will be tested, and what success should look like. This is what builds test plan, and this is what was written in this particular definition right here. Now, the key elements of test plan include test objectives, what needs to be tested and why, test scope, what's included and what's not in the testing process, test strategy, the approach to testing including the type of testing that you're going to add, test environment, the artificially simulated environments to check how real users will interact with your application, test deliverables, what documents or reports will be created from the test, test schedule, the timeline for testing. Obviously, the higher priority testers are tested first, then the next lower priorities are tested. Roles, obviously, who's in charge of testing what sections of the application. Entry and exit criteria, when testing starts, and testing is supposed to be completed when you have tested like 80% of the software, at least 80, because sometimes you don't know when or where the bug is going to pop up from. So in such a case, you have to predefine the entry and exit criteria. And according to you, it should be that at least 80% of the application is tested. Then the exit criteria will be fulfilled. Lastly, we have risks and mitigation plan. That in case if a potential bug that we did not notice, if the customers noticed it before you, then what is your exit plan? What is your backup plan? How would you deal with it? That's risk and mitigation planning. Moving on to our last question, what is a bug's life cycle? Can you walk me through it? Now, say you had a potential problem, like in the last case, risks and mitigation planning. You had a bug, your developers didn't notice it, or your testers didn't notice it, it was noticed by your customers. How would you handle that? That is a bug's life cycle. Let's go through this. Now, a bug's life cycle, also called as a defect life cycle, is a sequence of stages a bug goes through from the moment it is discovered to when it is resolved or closed. Now, there are a lot of steps in a bug's life cycle, starting from new, assigned, open, in progress, fixed, retest, verified, and closed. So now, let's understand with the help of an example. Say you have a ride-sharing application like Uber or Ola. You have built your own ride-sharing application. Now, there is a bug which suddenly popped in from the payment part. There were some unexpected issues with the code which nobody checked. And now this bug is affecting every other user who's using it. What's happening is that this bug is making users pay twice. Say if I'm going from here to someplace and the ride should charge me 100 rupees, it is charging me 200 twice. So this is affecting a lot of people, and people are losing their money because of this. But one of the users actually thinks about this. I usually go through this path and I only pay 100. Why should I pay 200? There's a bug in this. And what she does is she reports it to the tester. And the tester comes to know about this bug and they label it as a double charge bug. And the life cycle of the bug begins. Or the life cycle of the double charge bug begins. Now, the first stage is the new stage, in which a tester logs the bug into JIRA. Now, the JIRA and all our testing tools will explore them more in the upcoming modules. Next is the assigning phase, in which the bug is assigned to a certain backend developer, whoever coded it, or if that particular person is not there, somebody else, somebody more experienced than that person. Next, there is open. When they were trying to solve the bug, they actually realized that the bug is actually coming from the payment processing, and they have to go in there in progress. The developer modifies the payment logic and they have to update the whole code, and they have to update the existing code. Next, the fixed part, where the developer submits the fixed report. Repeat. Next is the fixed stage, where the developer finally finds out how to fix the bug and the bug is fixed and the final remedy is submitted to the main code, or it is documented. Then it is retested. Obviously, the quality analysis team, they retest it again just to make sure that the bug is not again popping up in other users' applications. And when finally it's made sure that it's not, that the bug is completely eradicated, it's the verification stage. The tester confirms that rides are now correctly built and the double charging bug is gone forever. Lastly, you have closed, or the resolved stage, where the bug is marked as resolved and the new update is pushed live. Now, that was your bugs life cycle. Now let's move on to our next module, that is the intermediate module. Now moving on to our intermediate level of questions with our 11th question, which is, what is regression testing and when should it be performed? Now, regression testing is a type of testing in which that new code changes do not introduce new bugs or negatively impact existing functionalities. Sometimes you're just you have written, this happens a lot if you have solved DSA questions. That's the most easiest way I can make you understand. If you must have solved DSA questions, you first try to do with the brute force method when you're solving the question. And you just think of the most logical way we can make this work. But once you get to the solution, you start thinking of optimizing the code. But once you start optimizing, you can notice that certain bugs keep on popping up in certain parts of the code. That is where regression testing comes in. Every time you make a change in the code, a new test is conducted to make sure that everything works as expected and nothing is breaking. That is called as regression testing. Now, say there's an e-commerce application in which you included a feature of one-click buy, in which the users can directly click on the item and they would just buy it. One click buy. No need of going to the checkout, no need of going through anything. Just you click on one click buy, it will automatically get processed and now it will show you the delivery date of when it is going to be delivered to your location. Now, in such a case, when you add this feature, it will affect certain other pre-existing features, such as adding items to the cart. It will affect that feature. It will affect applying discounts. It will affect completing the whole checkout menu. It will affect all of these features. Now, you have to obviously keep on performing tests. You have to perform tests on add items to cart. You have to do tests on applying discount. You have to do test on completing checkout to just see what changes or what new bugs have creeped into your code because of the one change that you made. That is called as regression testing. Now, when should it be performed? After a bug fix. Just because you have smashed out a bug doesn't mean that the whole code is now bug free. There will be some other hidden bug which will still be there, which might not be, you might not find it in the first try. Maybe you'll find it later on, but it will still be there. That's why regression testing is conducted, to keep on checking the files over and over again so that these hidden bugs are also squashed as well. Next, after a new feature is added, like I told you about the one-click buy feature. Next, after code refactoring, that is after optimizing your code, there are certain features which will still throw errors. Then before release or deployment, such that whenever your software is about to be produced or released into the market, at that time also you have to test it so that you can make sure that the customers are not the ones who are telling you that this issue is there. Your tester should tell you that this issue is coming and we should fix this. Moving on to our next question. What are the differences between smoke testing and sanity testing? To understand this, consider a scenario. Smoke testing is like trying to check if your car turns on. You're not checking anything else. All you're checking is if your car is turning on. The most basic, the most essential feature of a car. Can it turn on? That's smoke testing. Sanity testing is checking a feature of the car, such as is the car's GPS working correctly? Or in technical terms, smoke testing is a preliminary test performed on a software build to verify that the most essential features are working. Whereas sanity testing is a focused and narrow set of tests which is used to verify that a specific function or a bug fix is working as expected. Now, if you say you have an e-commerce application, what smoke testing does is it checks the essential features of this application. What are the essential features of an e-commerce application? That the home page is loading, the login page is working, the users can add items to the cart, the checkout function is happening, the prices and discounts and everything is visible in the checkout. These all are the essential features which make up an e-commerce website. So this all is checked with smoke testing. That can your application do the basic functions? Sanity testing is, say you added a feature for applying discounts. You added the feature of discount coupons. Now, such a feature is tested in sanity testing. The main difference between both of these is that smoke testing covers a wide range of tests. If you see homepage, login, these are all different modules. It's covering a whole broad range of modules, but it's shallow. It's not very deep. But sanity testing focuses on one item and it's very deep. It goes very in-depth test and it performs a very in-depth test of that one functionality to make sure that it is working. So smoke testing is broad but shallow. Sanity testing is narrow but deep. Moving on to our next question. How would you prioritize test cases when you have time constraints? There are a lot of ways you can do, but the main one is test case prioritization. Now, this is a method in which you rank test cases. You're ranking test cases based on their impact, risk, and importance. The goal here is to maximize defect detection with minimal efforts, because like we talked about in earlier, some features are more likely to cause a major impact on your application as compared to some other low risk features. So in such a case, you can prioritize different test cases, such as the login and the security and the session management of a banking application is more important as compared to providing dark mode or customized theme for the same bank application. Now, how to rank test cases based on their impact, risk, and importance? First one you can do is risk-based prioritization. That is, test the riskiest part of the application first, such as the login module, the sign-in module, the registration module, and all of. And if it's a bank application, the transaction module. Next, you have business critical features. First, test the features that customers mostly rely on, such as if it's a shopping website, then naturally the customers rely most on the login, the checkout, the search bar. Make sure you test these features first. Next, frequent and recent changes. If you have changed a certain part of your code or if you have fixed a bug, you've optimized the code, check that, because there's a very high chance that that feature must have introduced some form of bug in some other parts of the code. Lastly, you have customer facing features first. Prioritize what users see and interact with. If you had the user interface is the first thing that the users would see. So even if there's an issue in your database, then also what the users see is what matters to them the most. So make sure that that issue is fixed, because that will not cause a public outrage. And by the time that happens, you must have fixed the issue already. So these are the 4 important ways you can prioritize test cases when you have time constraints. Moving on to our next question. Explain boundary value analysis and equivalence partitioning with example. Equivalence partition is basically dividing the input data into partitions, into groups, where all inputs in a given partition are expected to produce the same behavior. Don't get confused. We'll look at the example so that you can understand better, but first understand the technical definition. And your boundary value analysis, or BVA, it focuses on testing the boundaries of input ranges, as errors are more likely to occur at extreme values rather than the middle values. Now let's understand this with the help of an example. Say you're building a party invitation form, and in this form it's written that only the ages from 18 to 60 are allowed in the party. So any person who is less than 18 or any person who's more than 60 is not allowed in this party. Now, if you make equivalence partition for this, equivalence partition will basically divide this into 2 classes: valid class and invalid class. Now, any number which comes between 18 to 60 will be valid, and any number which will be less than 16 or greater than 60 will be invalid. That's equivalence partitioning. Now, however, in case of boundary value analysis, minimum valid and maximum valid. So minimum valid is like the edge cases. If you see both of them, 18 and 60, both of them are edge cases. Now, the errors are more likely to happen at the edge cases instead of this middle cases. As in,
if you take any value from 80 to 60, if I take 30, 20, 25, any value, it'll all yield the same result, that yes, you are allowed to come to the party. But 18 and 60 are the edge cases, which means that they're more prone to cause errors in your code. Moving on to our next question. What's the difference between alpha testing and beta testing? Let's understand this with the help of an example. Say there's a chef who's a very famous chef. He's cooking in his own kitchen. He cooked a brand new dish which he's holding in his hand. He tasted it, he really liked it now. This is called as alpha testing. When your internal employees or the internal people who are working with the software, they test it, that's called as alpha testing. Now, if the same dish is given to a small set of volunteers, that situation is called as beta testing, where outside people, not the main customers, but a few volunteers, they test out your application to see how they like it. That's called as beta testing. Or in technical terms, alpha testing is basically a form of user acceptance testing performed internally by the organization's developers, testers, or a selected group of employees before releasing the product to external users. And beta testing is a phase of software testing where the product is released to a limited external audience, the real users, but not the actual customers, but volunteers, to identify real world issues, usability concerns, and performance problems before the final release. So, if we talk in terms of software, say you have a shopping website, alpha testing would be when your employees inside the company are testing the application. They find out bugs, they fix the major bugs before letting the outside users try. And beta testing would be if you hire like a small group of volunteers, you give the app to them so that you can see how real world users will react to your application. Now these set of people that you have given your application to, they can report multiple errors such as slow loading times, confusing features, or app crashes.
Now, moving on to our next question. How do you handle a situation where the developer doesn't accept that it's a bug? Say that a situation occurred in which a user was browsing through an e-commerce website. Now, she places an order to buy a particular item, and she pays the money as well. But what becomes a problem is that the order doesn't go through, and although the money is deducted, the order is still not placed. Now, you as a tester, you notice this error because this customer reports this error, you notice it and you identify it as a potential bug and you communicate it with the developer. However, the developer rejects it, saying that it's normal because when she was paying the money, the developers is whatever he had developed, that particular payment gateway was working. The issue was with the users' internet connection. So that was affecting just this one user, right? So it's not really an error. The developer puts an argument back and this person does not accept that it's a bug. How do you now such a situation can obviously be frustrating for a tester, but how do you handle such a situation? Starting with, you can provide proofs. You can provide log, screenshot, or videos to give undeniable proof that if an order is placed, the money should not be deducted. Even if the customer's network is slow, the money should not be deducted. The whole process should get cancelled, or if the money did get deducted, it should be refunded to the user because the order did not get placed. Next, point to the requirement. Refer to the requirements and specifications to show how the expected behavior is differing from the actual behavior. In an expected scenario, the money was not supposed to be deducted because the order was not placed. But in this scenario, the money is getting deducted and the order is not getting placed either. So next, you have explain the real world impact. Provide clear steps so that the developer can see the issue firsthand. Next, ask questions instead of arguing. So it's very normal for you to get frustrated. So don't go there and start screaming at them. Instead, engage in open communication to understand the developer's perspective and so that you can both find a common ground instead of your way or the developer's way. Next, if nothing works, you can escalate it to the right people. Escalate the issue by, if necessary, by involving a product manager or team lead for a final decision. If the developer is still not ready to listen, then obviously you'll have to escalate the issue further. So these are the 5 ways in which you can in which you can handle a situation where the developer doesn't accept that there is a bug in the system. Moving on to our next question. Have you worked with test management tools like JIRA, TestRail, or HP ALM? Now, all these 3 tools are very important if you are a manual tester. Instead of using Excel sheets, these tools provide a more efficient and easier way and with easier interfaces so that your manual testing is performed in a much more better and efficient way. Now, what are these? HP ALM is although an enterprise software. It defines test cases and links them to business's need. It tracks and monitors test execution. If the test case fails, it is assigned to JIRA. Most of the times, these are combined with each other. Like JIRA and TestRail are combined a lot. HP ALM and JIRA are combined a lot because JIRA also allows you to assign it to a particular person. That's why JIRA is preferred a lot in the manual testing industry. TestRail allows you to write test cases, execute track results, mark tests as pass, fail, blocked, and generate reports. JIRA, if a test fails, it gets logged into JIRA. The defect gets assigned to a developer who fixes it and updates the status. The tester retests the issue before closing it. Now, even if all these things didn't go into your head, you actually need to have a first-hand practice so you can understand how these things work. Although HP ALM, you'll have to watch videos because it's an enterprise software, so you'll have to buy it. HP ALM is usually it's used for large enterprises that need end-to-end test management. JIRA and ALM, you can actually go around, sign up, and practice for them. TestRail is greater for small teams that want a simple and effective test case tracker where your team is not so huge, but you still want to use something, so you don't need JIRA in that case. You can rather go with TestRail. JIRA is again used where you have a good team size and you need to manage multiple teams and you need to assign the errors and everything. You need new errors getting launched. You need new product features getting launched. It's not just for errors, JIRA. JIRA is also used for product development's whole life cycle as well. Going on to our next question, what is ad-hoc testing and how does it differ from exploratory testing? Now, if we talk about ad-hoc testing, what happens is you can open the app, tap randomly, you can try entering emojis in the delivery address, you can order food and close the app midway to see if the order is still going through. You can swipe left and right rapidly just to see if everything is working as it's supposed to work. Exploratory testing, on the other hand, is learning how the app works. That is, you don't have a formal documentation of how it's happening, neither in ad-hoc, neither in exploratory, but you're trying to learn and you're trying to document everything. You're trying to test the edge cases. Test cases are the ones which are more likely to cause an error. So you test the edge cases. You check how the app is behaving with different internet speeds, if it's crashing or loading, and you take notes of strange behaviors and report issues logically. Now, or in technical terms, ad-hoc testing is mostly an informal, unstructured testing approach where testers randomly check the applications without predefined test cases or documentation. In case of exploratory testing, it's a structured yet flexible testing approach where testers simultaneously learn, design test ideas, and execute tests on the fly. Now, although these two might sound similar, the main difference between ad-hoc and exploratory is the documenting part. In ad-hoc, it's like you have launched a new feature and you just randomly go and check just to find any hidden bugs. You just randomly start typing stuff. That's ad-hoc testing. But in case of exploratory testing, it's like when you don't have a documentation or a guide as to how to test it. So you yourself go around and test the features. Now the thing is, you document everything, you write down everything. But in case of ad-hoc, you're not doing that. So that is a major difference from both of these. And ad-hoc is not a structured approach. It's like you're just doing anything just to see if there are any hidden bugs. That's like the last stage. But exploratory happens when you don't have a proper testing guide, but you have to test it anyways and you have the time, so you go through the test manually, you write down the test cases, and then you prepare the documentation. Moving on to our next question. Explain the difference between severity and priority when reporting a defect. Let's understand the difference between both of them with the help of an example. Say you were going on a road trip. Now what happened is that two issues happened at the same time. Number one, the brakes stopped working. Number two, the radio stopped working. Now, which issue are you more likely to address? Obviously, the brake stops working issue is the one that you're going to address first. Now, in case of severity, if you look at the definition, severity is how badly a defect affects the system. Such as in case of the brakes affecting the system, it was a critical situation because you have to fix the brakes immediately. It's a very, very important and critical situation that needs to be addressed right away. Now, priority is obviously how quickly this issue should be fixed or how quickly should we address this issue. Now, obviously, a brake failing is a very severe situation, so it needs to be fixed ASAP. And if you look at the formal definition, severity is the impact a defect has on the system's functionality. It is determined by the tester and focuses on a technical aspect of the defect. Now, there are actually a lot of stages when it comes to determining the severity. There's a critical stage where the app crashes on login. When a payment is deducted but the order is in place, that's a high severity situation. The UI alignment is broken, but it's functional, so it's a medium level of severity. Now, there's a minor spelling mistake in the text is a very low level of severity. Next, you have priority. Now, priority is an urgency of how quickly you need to fix the error. It is usually set by the developer or the product manager based on the business's needs. Now, again, there are different stages when it comes to priority. There's high priority, like when the website is crashing on checkout, it's a very high priority. The search bar isn't working, but the users can still browse, is a medium priority. Company logo being slightly misaligned is of low priority. Now let's look at certain scenarios so that you have a better understanding of severity and priority. Like a payment is deducted, but the order is not placed. The severity is high, priority is high. Now, checkout button is hidden on mobile phone. Now, this can crucially affect the business. Hence, it's a very critical severity. The priority is also very high. Now, there's a minor typo in the product's description, is a low severity, low priority, and the company's logo being misaligned. It's not that severe, as in it might not break the whole website, but the priority is medium because obviously the company's logo is crucial again for business. Moving on to our next question. What are the different types of non-functioning testing and why are they important? It's actually a very important question. Why do you even think non-functioning stuff are important? Say, you buy a new mobile phone. Now, other than checking if the phone is turning on, other features are also essential, such as, is the phone fast enough? Am I able to open apps? And is the app opening at a lightning speed? Does the battery last long? Do I have to keep on charging my phone? Does it work well with weak Wi-Fi? Does my phone completely stop network connectivity when a weak Wi-Fi is connected? Is my personal data safe? Is my data being leaked to someone? Now, all of these issues are different types of non-functional testing, such as performance testing, endurance testing, load testing, and security testing. Now, these non-functional requirements, although they're not crucial to make your phone run, but these aspects still matter because if the phone functions correctly, a slow phone is still a bad phone. Or in technical definition, it verifies the quality attributes of a system rather than its core functionalities. It checks how well the software performs under different conditions. Now, there are different types of non-functional testing, such as performance testing is there for speed and response, load testing for handling multiple users, stress for system breaking, security for protection from hackers, usability for ease of use and design. Now, as to consider why it's important. Say you were having a bank application. You ran all the functional testing, all the crucial functional testing, there's all the core components that the login is working in the bank application, money transfers is happening, account balances are displayed, every functional component is working. However, you forget to test or incorporate the non-function aspect of this particular bank application. Now, because you didn't test it properly, what happens is that the app takes 1 minute to load, leaving a really huge bunch of frustrated users because you open the app and then you have to wait for 1 minute for the application to open. Next, it crashes when 10,000 people try to access it at once. It's very poor at load balancing. Next, hackers, because the security was not there, hackers stole the login credentials. Now, to make everything worse, the app is working on Android, but it's not working on iPhone. Now, due to all of these misfunctions, eventually, users stopped using this application and it was banned in the market. Hence, non-functional testing is equally as important as functional testing. Now, moving on to the more advanced questions, we have our 21st question, which is, how do you ensure maximum test coverage with limited resources? Now, say you have developed, your development team has developed a mobile banking application. Now, you have to get this tested. However, at the moment, your team of testers or your testing team is facing a shortage of people within the testing team, meaning you only have a few amount of testers with you. Now, you have to make sure that the maximum areas which can result in critical failures are tested first. How do you ensure that? Or how do you ensure a maximum test coverage which covers all the riskiest features? Now, when you're testing this application, you can essentially divide it into two groups, which is group number 1 being your low risk features and group number 2 being your high risk features. Now, when we talk about low risk features, we're essentially talking about features such as your dark mode or light mode, custom application themes where you can integrate any app theme that you like. Then there's push notifications, the notifications that you can see on your phones. Or maybe you can integrate a chatbot, an AI chatbot for frequently asked questions so that you can answer that. These are all the low risk features which would not affect your system's performance in market, not that much. But there are some high risk features as well. Now, the high risk features include your login logout, session management, payment processing, and QR code payments. Now, all of these things are very, very crucial. Login logout, again, a user's bank details, which can only be accessed after logging into that user's account. So again, login logout feature becomes very important. Session management is very important because if the session is not handled properly, another person, say a hacker, can attack the system and steal the user's sensitive credentials. Payment processing is again important. There are multiple SQL attack injections. There are man-in-the-middle attacks using which your payment line can be attacked and then the money can be taken into, or the money can be wired into some other account. QR code payments, the QR should exactly be, you should only be able to see the receiver's correct QR code. It should not be attacked by a hacker, and it should not be showing some other accounts' QR code as well. So all of these features are high risk features, and it's crucial that you test them no matter what. Now, obviously, you highlight these features, that these are the high-risk features, these are the ones that I need tested, and then your testing team, instead of testing out the low-risk features, they spend maximum amount of their time testing out the high-risk features. And now, in such a way, your mobile app can be launched into the market with all the necessary and important features tested out, and you're getting the maximum coverage as well. Because if you see, these are also the most interacted with features in your application. When a user is logging into a banking application, they don't really care about the custom applications or the day mode or night mode. What they really do care about is the payment processing, QR code payment. If you also open Google Pay, you don't really care about how your Google Pay looks. All you care about is paying the money using Google Pay. That's exactly what I'm talking about here as well. Or in technical terms, maximum test coverage involves strategically selecting and prioritizing test cases to cover the most critical, frequently used, and high-risk parts of the software. Now, what are the generalized strategies that you can use to ensure maximum test coverage with limited number of resources? Some strategies include test where failure would cause the biggest issue, such as I told you about the QR code and the payment processing, where the hackers are more likely to attack. So test those features. Ensure major portions of the code base are tested. Now, obviously, in case of a mobile banking application, the login, logout, session management, QR code, and the payment processing are the core of that particular application. So when you cover these, you are naturally covering like 70 to 80% of that application, meaning the major portion of that code base is already tested. Regularly review test cases and eliminate the redundant ones. Sometimes, because all of these different modules, a module for payment processing, a module for payment transaction, all of these are interconnected, right? So sometimes it happens when you're testing, you might have to test the same thing over and over again. So when you notice this, you can just remove that particular test case so that the number of tests that you need to conduct reduces. Moving on to our next question. Can you describe risk-based testing and how would you implement it? What is risk-based testing? To understand this, let's take the help of an example. Say you own a parachute company. Now, what are the main features you would consider when you're testing out your parachute? Obviously, are the straps working? Is the emergency backup in case the parachute fails to open? In case the parachute fails to open, is the emergency backup working? Is the parachute deploying as it? Is it open? Is it opening properly? Is it able to glide through the wind properly? Those are the things that you would pay more attention to. Now, again, features like your logo and the colors are important, but they're not that important as much as the straps or the emergency backup or the air gliding physics and everything. It's not that important. This logo and colors are not that important as compared to these important features. Now, even if some emergency stuff happens, as in your glider loses control of his parachute, in that case, the logo or the colors will not help that much as your strap strength and the emergency backup would. So, in general, in risk-based testing, you prioritize the most important and riskiest part of the system instead of treating everything as equal. Or, in technical terms, it is a test strategy where test efforts are prioritized based on the likelihood and impact of potential failures. How would you implement this? You can assess what could go wrong and its impact, such as in the case of your parachute. You know that a parachute failing to open up is a very crucial or a very important thing that needs to be tested. You need to have a backup in case this happens. Assess what could go wrong and its impact. There's also this, for this colors and everything, you can also say that the colors look ugly. You can even say that the colors look, they're not vibrant enough and they're not making a good contrast with the environment. These are also issues. These are also potential issues. However, these are not that severe as compared to the straps not being strong enough. Because what if a person is on the parachute and the straps just loosen up and the person just falls? At that moment, the colors or the logo will not save the person. So that's what I'm talking about. You have to assess what could go wrong. The colors, maybe they're not matching with the environment, and the straps loosening up. These two are a fact that can go wrong, but the impact it's making is what's more important. And rank them based on severity and likelihood again. Like the buckles are loose, this logo looking weird will come below that. Next, allocate more testing efforts to high risk. Again, if the buckles are loose, if the straps are loose, if the emergency backup is there, spend more time testing these features instead of the colors or the logos. Moving on to our next question. How would you handle a situation where the requirements changed the last minute? Now, this is a very interesting question. Say you were having, again, your mobile banking application. You were about to launch it into the market. Everything was fine and perfect. Suddenly, your security team appears out of nowhere and they tell you that they need to integrate MFA or multi-factor authentication because it's very important from a security perspective. Now, you have no choice other than to integrate MFA within your application. But how? Because MFA is essentially another login feature. Now, it can affect your whole application at once because when you code, you must have noticed that if you have already built, say, even if a website you have built, a very simple website, even if you add one line of code, there's a very high chance that the already pre-existing code will crash at once. This happens a lot in React. You'll add one line of code and the entire application just crashes. So now you cannot afford this because you're about to launch this application. So you cannot afford to have a prolonged production delay. Hence, what do? Now, in such a situation, check how MFA is affecting the rest of the security system, such as your login and registration are there. How is MFA affecting that? Add test cases for MFA flows. So when you're adding MFA, it will affect your login and your registration page. So after you integrate the code, if nothing is failing successfully as of now, test it. Keep on testing so that you can find some hidden bugs or something which you couldn't see in the beginning itself. Next, deploy MFA as an optional feature. If the time constraint is very less, say if you're deploying it tomorrow, then obviously you cannot integrate it today. So in such a case, if MFA is still important that you have to include, then deploy it as an optional feature so that maybe because not every user would immediately go and start applying for MFA because MFA takes some time for the user also. So in most of the cases, the users don't really include MFA. So in that case, even if there's something wrong with MFA, only 50% of the or 50% or less than that of the users will know that something is wrong. And the rest users will not know at all. So in such a case, not a huge population will come to know that there are some defects in the application. And by the time they'll know, you would have fixed it. Now, this was a very specific one for this mobile banking application. Now, let's look at let's generalize this so that we can apply it for any application. So, there are a list of things you can do: impact analysis, prioritization. Let's look at them one by one there. So, impact analysis is basically identifying how the change affects the existing code, timeline, and resources. Like we talked about the login and the registration page, how MFA is affecting the login and the registration page. Next, you have prioritization. Focus on critical changes first, deferring minor ones if necessary. Like I said, login and registration are very crucial. So if it is affecting those features, like it will majorly affect those features. So prioritize them. Maybe there are some minute changes which happened in the rest of the code. The priority will be considerably low as compared to login and your registration page, which is a severely affecting one in case of your mobile banking application. Next, incremental implementation. Make changes in manageable steps rather than overhauling everything. Obviously, if you add a whole block of code into your already pre-existing code, there's a very high chance that your whole code will stop working. So instead, make one line change first, then make the second line change. And at that point, you'll notice that something's wrong. And then you go around, fix it. Then you add another line, then something goes wrong, you fix it. In such a way, your application will not crash and you will be able to integrate more lines of code more effectively. Lastly, you have risk management, which is identify potential pitfalls and adjust accordingly. Like I said, if there's a severe time constraint and including MFA is causing major pitfall or major risk factors and you don't have enough time to eradicate them, deploy it as an optional feature so that the pitfall or the drawbacks or the users finding out that there's a major defect will be considerably low. Moving on to our next question. What strategies would you use for UI testing, compatibility testing, and cross-browser testing? Before understanding what strategies you would use, you need to understand what UI testing, compatibility testing, and cross-browser testing mean. Now, UI testing is essentially ensuring that your application or your website looks good and works as expected. Now, this is important because there are a lot of times when the UI or the user interface is very beautiful, but you are not able to navigate through the app. you're not able to find the search bar, you're not able to find the login button, then in such a case, there's no point. Even if your UI is extremely beautiful, if you cannot use the application, there is no point. So at the end of the day, your goal should be that the UI is attractive enough to attract the users, but at the same time, it should be easier for them to navigate through the website as well. Next, we have compatibility testing, which is that your device runs properly on every devices, such as laptop, tablet, phone. It should run the same it should run the same everywhere. Next, we have cross-browser testing. That means your website is behaving consistently across different browsers, such as be it Safari, Firefox, Chrome, or your Microsoft Edge. It's working the same everywhere. Now, how do you ensure that these are happening? Starting with UI testing. For UI testing, you can do manual testing and visual regression testing. With manual testing, what you can do is collect a few amount of volunteers, and then this is also called as beta testing. So in case of manual testing, you can collect a small amount of volunteers and then make them give different versions of your UI and then make them use all of these different versions. And then whichever version had the highest amount of user interaction, you can use that version for your final application. Even Instagram does it. Instagram keeps on changing its UI. They do A and B testing where they launch like 2 different versions of their application. And whichever version is having more user interactions, they finalize that version for the final product. Visual regression, as soon as you add a new feature, obviously there will be a bug. Keep on testing it, keep on changing it so that it's more easier for the user to use, but at the same time, it's attractive enough. Next, you have compatibility testing, which is for this, if you have Android, you'll have to go back and test around all the Android versions. For iPhone also, you'll have to check around all the iPhone versions. Windows, you will have to check all the Windows versions. The network condition testing, as in if according to the networks, is it loading? Is your website able to load under different networking conditions? Lastly, we have cross-browser testing. For this, you can just deploy your application on cloud and then see if it's getting hosted there. And if it's hosted there, then obviously it will be hosted everywhere else. And then you can test it on different resolutions as well to see if different browsers are able to support the different resolutions for the browsers. Moving on to our next question. How do you test an application without any documentation? Now, this is where this is one of the points where a fresher can struggle in manual testing because you don't have a documentation and you have to test an application. Now, if an experienced tester is there, they must have tested an application like this before. So they might have some intuitions, they might have some knowledge about how to do this because they've already done it before. So they would know about how to test this software as well. But if it's a fresher, then it can be difficult for them. However, there are different strategies and methods which can help you here. And one such testing method is called as exploratory testing. What happens in exploratory testing is it's an iterative hands-on testing methodology where testers investigate the software without predefined scripts or detailed documents. Now, exploratory testing is also compared with black box testing and reverse testing. Black box testing is where the users test the application without knowing how the internal workings are happening. And reverse engineering is when you have the final product and you debug and you break it down and you try to go back to the first stage from the final stage. That's reverse engineering. Now let's try to understand this with the help of an example. Say you have a to-do application. Now, if you're conducting exploratory testing with it, what you do is you would go around try to interact with the features, such as you would click on the add task button. Is the task getting added? You will type in on the input fields. You'll see if you're able to type in the values properly. You're able to add tasks more properly. And if you have tested a to-do application before, you can compare and contrast here, okay, what is supposed to happen and what is actually happening. Next, most importantly, document everything. You're adding task and what if it's not adding? So you have to write that down. I clicked on the add task button, but it's not able to add the task into the existing list. So you can document such behaviors, then gather expected behavior. This again, for an experienced person, this will be easier. Like you can check out other applications which are following the same other to-do applications. They have the same framework, but that other to-do application is working like this. And when I click on the same feature, which this one also has, it's giving some different result. So you can document that as well. Then lastly, report your findings. Whatever you have documented, share that with your development team or with your product management team or whoever or with the concerned authorities. Now moving on to our next question. What challenges have you faced in manual testing? How did you overcome them? Now this is in manual testing, there are a lot of downsides as well. So when the interviewer is asking you this question, they are expecting you to at least be mindful about such an error, that there are obviously downsides to this, and the interviewer expects and the interviewer is checking to know that if you're mindful about such downsides of this as well, so you can test them out, but also let them know how you can overcome them. All right, so the first one we have, it's time consuming. Manual testing is inherently slower than automation because we all know that machines can test across multiple browsers, multiple versions. They can simulate an artificial intelligence, and they can do it at a much faster rate as compared to humans. Next, it is prone to human errors. Now, fatigue, oversight, and inconsistencies can lead to missed defects. Now, what this even means is that even if you miss one single bug because maybe you were getting tired or you were getting bored and you missed a very essential bug, now what happens is that that one missed bug can cause a massive disaster in the whole application, because sometimes it happens that one bug leads to another bug, and then that leads to another bug, and then at the end of the day, one feature in the front end is not working as expected, and you have no idea that the bug is in the back end and it's not in the front end. This can happen due to human errors. Next, reduce test coverage. Due to time and resource constraints, manual testing may not be able to cover all the possible scenarios, because manual testing can cause a huge production delay. Now, in such a case, if you assign a large chunk of the testing to manual testing, it can cause a lot of time constraints. Now, because of this, again, human errors are more likely to happen. Next, higher long-term costs. While manual testing has lower upfront costs, it requires continuous human effort. That is, if at the beginning you might think that manual testing is costing you less as compared to automation testing. However, in a prolonged period, because human manual testing requires a prolonged period to finish the test, in such a case, it will cost you more money as compared to your automation testing. Next, you have repetitive and inefficient. Running the same test cases repeatedly is tedious and unproductive for testers. I've told you this before as well. I mentioned this point about removing redundant test cases. That is the same thing. Sometimes you have to test, and because these modules are interlinked, you might have to test the same module over and over again. So in such a case, after you have, say, made a new, you've included a new patch or included a new bunch of code, after you check it, you think, oh, I've already tested this before. It's going to yield the same results as well. So in such a case, there is a very high chance of maybe the person not paying attention, and then a possible new bug being generated out of that. So these are the main errors that a manual tester can face. Moving on to our next question. Explain monkey testing and gorilla testing. Are they useful in real world scenarios? Now, I know it sounds funny, but it's very beneficial. Now, monkey testing is basically tapping randomly to see if the app is crashing. Now, it's random, unstructured, and meant to find unexpected issues. Now, monkey testing basically signifies a frustrated user. Sometimes your phone hangs up, and at that point, you get very annoyed that your application is not working. At that moment, there are situations where a user can get really frustrated and they start tapping the phone very violently. Such a testing is called as monkey testing. So, then in the real world, if your app hangs and a person starts doing this, your app will not completely nothing crucial is breaking at that point. That is why we have monkey testing. Next, we have gorilla testing. Now, gorilla testing, pressing the same button 1,000 times to make sure it doesn't break. And it's focused, repetitive, and stresses a specific part of the software. Now, why we do this? We do this mainly because of this load testing. Load testing is when, say, there are 10,000 users using your application at the same time. Now, you have to check if your application is able to manage these 10,000 users effectively. It's not hanging, it's not breaking. That's where gorilla testing comes in, because gorillas are very focused. They keep on pressing the same thing. So that's where your gorilla testing comes in, to check if your app will break when a huge amount of users are using the same features at the same time. Now, the reason why they have named is in monkey testing and gorilla testing, when I researched about this, what I found out is that monkeys are very much more playful, and like they keep on jumping around, they keep on tapping at random stuff. So because of that, the test is called as monkey testing, because you keep on tapping on random stuff. You don't know what's happening. You just keep on swiping, tapping, whatever you see, keep on pressing it to see what's going wrong in the application. But gorillas are much more, because of their sheer strength, they keep on smashing the same object repeatedly. If you must have seen NG or animal documentaries, you must have seen that's how they are. So in gorilla testing also, you're pressing the same button continuously. So that's why they are labeled as monkey testing and gorilla testing respectively. Now, in technical terms, monkey testing is a type of random testing where the system is tested with arbitrary inputs to check for crashes and unexpected failures. This is mostly used to check for hidden bugs. You never know. Sometimes, when you're usually checking it in a very systematic order, you don't see a bug. But when you randomly start there is a very high chance when you randomly start tapping it, you can find unexpected bugs. Next, gorilla testing is a repetitive brute force testing approach where a particular model or feature is tested extensively to check the feature's robustness and stability. Stability, like I told you, if it can manage multiple users at the same time. Moving on to our next question. How do you handle duplicate or conflicting bug reports in a test cycle? What is a duplicate report in a test cycle? Now, say you have a website, and in this website, the search bar suddenly stopped working. You had added some patch to the existing code, and the search bar is not working. Now, the users who are using this application, this website, they all lodge the same complaint. Now, although they have different email IDs, they have written different queries, everything is pointing to the same error, that the search bar is not working. Now, in such a case, you would not reply to every individual person here. What you would do is you would draft one email, include all of these users in that thread, and then send it to them. Similarly, in case of applications, say if one user reports that, say you have one report saying that the app crashes when you press the submit button, and there's another report that pressing submit after entering some data, the app is crashing, the app is stopping unexpectedly. Both of these reports are pointing to the same thing, that clicking on the submit button is making the application to crash. Now, a tester obviously can see this, they can link them together. Both reports describe the same crash. Now, in such a way, instead of lodging them as two different bugs, you can lodge them as one bug. So this is called as a conflicting bug or a duplicate bug. Now, how to ensure that this doesn't happen? Tools like JIRA, Bugzilla, or Trello help detect duplicate bugs and track conflicts. Before logging a new bug, check if it already exists in the system. If two reports are about the same issue, merge them and add reference to keep everything in one place. Clear documentation prevents wasted efforts on redundant reports. So make sure that every time you're lodging a bug, write it down in the documentation or enlist it into the documentation so that the next time they find a bug, they can compare it and check if it previously exists. If it doesn't, add it. If it exists, merge them together, add the references, keep it there. Moving on to our next question. What's the role of SQL in manual testing? Can you write a simple query to verify data in a database? Now, SQL plays a very important role. Let me tell you how. Say there's a user who is interacting with a website and there's a database to facilitate this interaction. The database stores all the data of the user. Now, this user updates her profile in the website. Now, how do you make sure that this profile is actually updated in the database as well? What if it's only updated in the user interface? What if it's not really updated in the database? SQL makes sure that this particular user who updated her profile is actually being updated in the database as well. Now, why do testers use SQL? They use it to ensure that the data entered through the application is stored correctly in the database. That is, data integrity is there. That if I am making a change if I am changing my Instagram's username here in my phone, then it should also change in the database and it should also update it everywhere else. SQL makes sure that this is happening. CRUD operations as a create, read, update, and delete operations, are these working correctly? Comparing the front end with the back end, like I said, front end it's showing some other data, back end it's showing some other data. This should not happen. Both should work together. Only the data from the back end should be displayed in the front end. That should happen. And if a data is being modified in the front end, it should get updated in the back end. This is facilitated using SQL. Now let's write a SQL query. Now let's see, we have a lot of tables here. Let's use this orders. There is an orders table. Okay. Let's create a new table. Create table orders. It should have an ID as the int, a name, item name as varchar. What else? Status. That's also varchar. Okay. Now, let me comment that out. What do we do? Okay, now insert into orders. Order ID 101. Say I'm ordering a laptop. Status is confirmed. Okay. Now, now you can see that the ID with laptop is confirmed here in this database. Now, if in the backend this is confirmed, but in the front end, if it's showing that the order is still not confirmed, then that is an issue. And SQL can successfully show it. Moving on to our last question. How would you approach it if you were given a new feature to test with zero guidance? You have a new feature in the application, but you don't know how to navigate it through. You have not been told about it you've not been told anything about the new feature, but you have to test it. How would you do that? There are a lot of things you can do. Start testing immediately, apply exploratory testing, validate backend and logs, write test cases. What do these mean? Let's look at them. Start testing immediately, as in, don't wait for instructions. You're not going to get any instructions anyways. So don't wait for them. Interact with the features firsthand. You saw how we looked at how to interact with the to-do application. I told you how to do that. Similarly, just start interacting with it. See how it's, when you start interacting with it, you will start having a basic understanding of how it's supposed to work and how it's working. Next, apply exploratory testing. Test different scenarios and document everything down so that even if somebody else is testing it, or even if you are testing it, say tomorrow, you might not remember everything. But if you document it down, if you write it down, you will know, oh, this I've already done. So for your reference and for other people's reference, keep documenting everything. Validate backend and logs, such as use SQL, API calls, or DevTools to check how data is processed. Again, there is a very high possibility that in the UI, it's showing some different result, and in the backend, it's showing some different result. So to make sure that the data integrity is happening in both of the sides, you have to manually go around and check the API calls as well. Next, write test cases so that you can cover a wide range of scenarios. Obviously, you'll come to know about these scenarios after exploratory testing, and after you come to know about these different scenarios, write test cases for all of them and test them out, so that by the end you would have tested the new feature with zero guidance. And with that, we reach the end of this module. Thank you so much for tuning in, and I'll see you guys next time.